So how are we going to randomly choose a position out of our empty space list? How are we going to randomly choose one of these positions to spawn one of our rock prefabs in? Okay, so after the steel array loop, I'm going to set up random rocks. So let's create a variable. How many rocks are we going to spawn? This is a count, so it's going to be of type integer. That's going to equal. Now let's do some calculations and then return an integer. Now, okay, I used mathf.floor to int before. ParseInt is doing the same job. Okay, whatever value we put in here, it's going to convert that to an integer and then return it and give it the value to the variable. Okay, so we have an empty space list. Now, if we want to know the length of that list, we can use empty space list.count, and then we can multiply it by a percentage. Just say I only wanted 50% of the empty spaces to be rocks. I could say 0.5. So half of the total length of the empty space list, we're going to make rocks. Just to show this is working, let's just set it to 1. So every empty space is going to be a rock at the start. So then we need to loop through however many times we want to spawn a rock. For loop I is less than rocks to spawn. It's not coming up. Okay, so that's going to loop through however many times for what we've decided we're going to do there. Now first off, let's get a random number that's going to be an index position for our empty space list. So comment, get a random number. Random choice. Again, this will be a type integer equals random dot range, and we're going to set it start at 0, and then we have the empty space list count. Now, as I said before with arrays, when you're counting through a list or arrays, it actually starts at position 0, so we need to -1 so we don't get an array or index out of range exception. So this is going to pick a random position in that empty space list. Okay, let's instantiate that chosen at that chosen position. Let's instantiate rock at that chosen position. So let's just set the position in a separate variable so we can do the calculations outside the instantiate, make it a little bit easier to read. So variable rock position of type vector3 equals new vector3 Okay, so what are we reading? We're reading our empty space list, and at what position? At our random choice list position. IntelliSense doesn't want to work for me. And that's a vector 2, this is a vector 3, but in both cases we want the x position first. And the same thing for the y position, and like I said, everything is going to be zeroed on the x-axis, as you've already seen. Okay, so there's our position all calculated out. Making a choice. choosing a random position in that empty space list, and we're going to assign that a rock. So we have a block variable up here we were using to instantiate things into. Yes, block equals instantiate rock block, and at the rock position we just calculated, and keep the rotations to 0. Okay, let's just keep it all tidy like I did before. Block name is now a rock, and gotta do this differently. We have rock pause here, so let's rock position dot x for the x name, rock position y to give us our coordinates of our rock, and let's just make it a child of this transform again. Okay, now we've taken a value from the empty space list, so we need to remove that because it's no longer empty, it's now a rock. So remove that position from the list. So empty space list dot remove at, and we have our index position, which was our random choice. Okay, so what have I said here? Rocks are spawn times 1. So for every empty space we should get a rock. Let's just see if I haven't broken anything. I'm getting what I'm expecting to get. And there we have it. For every empty space we have a rock block. So let's test out what I was saying about the percentage. So if we said 0.5, we only want 50% of the empty spaces to be rocks. Let's try that out. Hit play. And there we go. We've randomly created a level. Taken some values from that list. And sorry, what was that list before? It was 140 something. Now it's down to 74. If I hit play again, we should get a whole different level. Okay, so let's imagine we've got a whole straight line up here. Stop. Hit play. And there we go. You can see that's not a straight line of blocks now, so we're randomly generating our level. Now before I go too far, I need to store this position in our level array as well, just like we are here. Now where I've said 2 for the integer value is unwalkable, I'm now putting rocks in the position, so I want to store a value of 1 in that 2-dimensional array. So store rock position in the 2D array. So, and just the same as we did here for the name, we know what position in the array we're using because we set the rock block position to that position. So the level array at this rock's positions x and this rock's position y is now going to be 1 for rock. Now the 2-dimensional array stuff probably isn't making sense now. What we're going to be doing is reading this array later for this kind of thing. It's basically to do with this whole question this fellow Mad Johnny asked. When you create an explosion, okay, so see a bomb was set off here. Now when the bomb does damage, it looks around itself. So if we know where the bomb is in our 2-dimensional array, just say this is position what? 3, 5, 7, 9, 11, 12. So this is 12 and coming up 3, 4. So we know the bomb's at 12, 4. So we can say, what is it 11, 4? If it's an empty space, continue the blast. And 12, what's that, 12, 4? So 12, 5, we can ask the 2D array, what's at 12, 5? Okay, at 12, 5 there's actually a rock, so we need to destroy that rock and not continue the blast. So this is where the whole 2-dimensional array is going. How we can read the information in that 2D array to determine actions. Okay, have I changed anything? I don't think I did. I just set up the random, didn't I? Now, unfortunately, a two-dimensional array will not show up in the inspector, so we pretty much have no way of reading that. The only way we can do it is ask it through a debug to return a value at a position. So we're going to have to pretty much trust that that's all working, this level array business. Until we start reading that level array and see if it's working or not, kind of have to leave it there for the moment. Now, while I've got this set up, let's have a look at what's going on. Okay, my computer went really slow there. I hope the recording's still okay. Now, it hasn't done it this time, but what I'm going to be doing is I'm always going to be starting the player off in the top left corner. So when I'm instantiating these random rocks, I don't want to fill up this position. Let's see if I can get it to happen. There we go. See, I want to put my player there, so I don't want a rock there. So I want a consideration for that. But also when BlastMan puts down his first bomb, he needs somewhere to hide too. So if he put a bomb there, he needs to run around this corner so he doesn't get blasted by the bomb. So I need to set that position to always stay blank as well, and this position. So we need 1, 2, 3 positions that need to remain blank when we're creating our random. So let's just, even when we're testing this, set this back to a 1. Okay, so we should get a full board, no spaces at all. Now I'm going to write in a condition that's going to leave these 3 empty. So that's why I've made it full, just so we can see that that condition is working. So let's bring that in. So where we're adding the space to the empty position, we need to do, wow, let's just set up a conditional for each position. So let's make sure we don't instantiate a rock at the top left corner first. So we've already added it to the list, but then we want to check if we want it to be an empty space, and if so, we'll remove that. So if empty space list, here's where it gets tricky. Empty space list count -1. So the last value, I've got a neat square bracket there. So we've added something to the empty space list. So then we count the length of that empty space list. And remember, it starts at 0, so we have to -1 here. So we want to check the values in there. So we want to check if that is equal to vector 2, and we want to keep a blank space of 1 on the x, and on the y, because it counts from the bottom to the top, I can't just say 1 on the y, because that'll be the bottom left. So I need to say the level size dot y. Now we're counting down -1 for the length of the array, and then -1 for the border. So this has to be -2. So if that first position is equal to that vector, we need to remove this that we just added. Remove at. And just like I calculated here, this is the position we're checking. So this is the position we want to be removing. Alright, so that's pretty long-winded and confusing. So let's just save that out and see if it's working like I'm hoping. So I hit play, and then the top left should be open. And there we go. So we have nothing. Make sure we're leaving an empty space for our player. Now you can see what's going on. Like I said, we need a place to drop bomb, and we need a place to hide. So we need to make sure this one's empty and this one's empty. Let's put some comments in to make this a little bit easier. Let's put it above. Player starts at the top left corner, leave an empty space. Okay, so now let's work on leaving a space at the right of the player, at the right position, at the next position to the right of the player. So else if, let's just set up my conditional brackets first. Now the same thing, we're going to be checking what is the vector2 stored in our last stored position, is equal to vector2. Now if we're counting along to the right one, so it's 2 on the x, and it's going to be the same on the y. Okay, so we're checking one block to the right of our player, but on the same horizontal, on the same y, on the same vertical. Okay, so it's the same thing here. If that returns true, we want to remove that block. So let's see if that's working. So now we should have an empty space for the player and an empty space to the right of the player. Okay, now we have it. So we can run along here, drop his bomb, but now if he drops his bomb here, he wants to come and hide down here so he doesn't get destroyed. So we need to make sure this one's also an empty. But now that I've confused you all by doing it once, let's just copy it all out and do it again. Leave a space below the player. Okay, so now in this case the x is going to be the same, but the y is going to increase, so y minus 3, and then the same thing, remove that. Alright, so that's very confusing, I know. That's why visually, hopefully you should see what's going on. And there we have it. So we've now made sure, while our whole level is going to be randomly generated, these 3 spaces never get filled with anything. Because just say randomly, there was a rock here, and there was a rock here. So the player would start here, he'd drop his bomb there, and he'd run around the corner, the bomb would go, okay? And that one will get cleared, and he can run up out the way and continue. This is just so you don't leave the player starting on a random level and having him stuck in a corner where he has to blow himself up. That wouldn't be cool. Okay, let me check everything I've got for this video. So, yeah, we've got the empty spaces set into position. We're creating our rocks, we're storing at the array. Now, I could make this into a variable. What am I going to call it? I guess we'll call it rock percentage. So let's create a variable up the top for that. Empty space data. It's all part of that, isn't it? So variable rock percentage, which will be of type float, equals, let's just say 0.6. A little more than half of the empty spaces are going to be rocks. So now we have our rock percentage. If I hit play, okay, we'll definitely have those 3 that are left open, and then 60% of the remaining empty spaces are filled with rocks. Okay, so again, if I just set that to 1.0, so all the rocks are in, except for the 3 that we have said no. They are reserved. Okay, so I'll save the scene, and then we'll move on to adding a player.